This video is about adding and subtracting rational expressions. We'll start by reviewing adding and subtracting fractions and then make connections with that process to adding and subtracting rational expressions. Let's get started. To begin, let's review adding fractions together. Okay, let's start here with number 1. I have 1/2 plus 1/4. Okay, now let me show you in a visual model what this looks like. If I have this as my whole and I have half of it, okay, and I have the exact same whole, but I have 1/4 of it. Okay, can I add those together very easily? Now I know that you're familiar with 1/2 and 1/4, and you probably know that the answer is 3/4. Okay, but the important thing is that I can't add these together because they're a different size of piece. So what I do is I change this one so that I have the exact same size of piece. Instead of writing 1/2, I think of it more as I have 2/4. Okay, and I do that by multiplying top and bottom by 2, so I get 2/4 plus 1/4, and now I'm dealing with fourths. Okay, and I can add 2/4 and one more fourth and find that I get 3/4 in total. Okay, so when you're adding or subtracting fractions, you have to have the same denominator because that is the size of your piece, the piece of the whole that you're working with. Now, in terms of rational expressions, the reason that I multiplied top and bottom of 1/2 by 2 is because that was the missing factor. That was the factor that 4 has that 2 doesn't. Okay, so we'll be looking at what is the missing factor that the other one has that this one doesn't. Okay, let's talk about how to do that with rational expressions. When the denominators are not the same, you want to factor the denominators. You will then identify missing factors. Again, it has to do with what does the other denominator have that this one doesn't. Okay? You will then find the common denominator by multiplying both the numerator and denominator by the missing factor. Then you'll keep that denominator and add or subtract the numerator. Make sure to identify excluded values, which actually I won't be doing in this video. I will focus on that idea when we get to solving, and we'll simplify if possible. All right, so let me scroll up here so I have a little more space to do these problems. Okay, the first thing that we do is we factor all the denominators. In letter A, number 5, I can't do a whole lot with the 5. Okay, but the 6b plus 8 has a GCF of 2, and I get 2 times 3b plus 4. Now, I ask the very important question of what does the other denominator have that this one doesn't? So if I look at this, what does that have that the 5 doesn't? And the truth is it's all of it. So I need to multiply both the numerator and denominator by 2 times 3b plus 4. Okay, and then similarly, I now look at this denominator and say, hey, what does that one have that this one doesn't? And the answer is that 5, right? Multiply this times 5 and this times 5. And now I have a common denominator. Now let's rewrite this so it looks a little cleaner before we move forward. Now I took the liberty of multiplying 2 times 5 to be 10 in the denominators. Okay. The next thing I actually want to do, just to save space, is I'm going to multiply this 2 times this 2b and get 4b and put that out in front. Okay, just to save space, I'm going to put it in front here instead of writing it again. So I have 4b right here. Okay, and now I'm going to distribute this 4b into both of these terms and the 5 into both of these terms. Next is a very, very important step, okay? I'm subtracting this entire second fraction, this 35b plus 15 over 10 times 3b plus 4. The entire thing is being subtracted, not just the 35b. So to remind myself of that, what I do is I change this into plus, and then make this negative and this negative, and if I had more terms in the numerator, I would change every term in the numerator of the second fraction. Okay? And then we will combine together, and my denominator, my common denominator, my same size of piece is 3b plus 4. Okay? In the numerator, I now combine like terms. I have 12b squared is the only b squared term. I have 16b minus 35b, so that's minus 19b, and then I have minus 15. Okay? Now, before I celebrate and think I'm done, I look at the numerator and say, can I factor that and get a 3b plus 4 out of it to cancel it off? Okay? And in this case, it doesn't factor very nicely, so this is my final answer. Okay, but be aware that sometimes it does factor down, and then you can cancel things off and you'll simplify it even simpler. Next, I want to look at number 2. Okay, again, just like before, I will factor both denominators, and I get x, let's see here, two numbers that multiply to be 6 and add to be 5 is plus 2 and plus 3. Over here, x squared minus 9 is the difference of squares, and I have x and x. And two numbers that's the number that squares to be 9 is 3 and 3, and I get plus and minus. Okay, so I factored both denominators, and I ask myself that very important question of what does this denominator have that this one doesn't? Okay, and looking at it, it already has the x plus 3, but what it doesn't have is the x minus 3. So I multiply top and bottom here by x minus 3, x minus 3. Okay, and then I reverse the question. What does this denominator have that this one doesn't? Well, again, it has the x minus 3 and the x plus 3 that I have here. What it doesn't have is the x plus 2. So I multiply both top and bottom by x plus 2. X plus 2. Okay, let's rewrite that. And so I'll kind of switch the order like how I'm used to seeing it. X times x minus 3 divided by my common denominator, x minus 3, x plus 2, x plus 3. Plus 3 times x plus 2. Now I'm going to rearrange the order so it matches perfectly my other one to show that they are a common denominator. Okay, now I'm going to distribute this term into this binomial and the 3 into this binomial and get, okay, so I have the same common denominator, and I combine things together. And that common denominator is x minus 3 times x plus 2 times x plus 3. Okay? And combining the like terms is addition. So this is the easy case where I just kind of add things together. So x squared is my only x squared term. And I have minus 3x plus 3x, which cancels out. And then I have a plus 6. This is what I get. And I'm really hoping you see the connection between this process and something like adding 3/4 plus 5/6. Okay? Again, you're looking, what factor does the other denominator have that this one doesn't? In this case, it's times 3 over 3, and over here, it's times 2 over 2. Okay? So you multiply top and bottom by that missing factor. Okay? You multiply them together and get 9/12 plus 10/12, okay? And then you keep that common denominator and combine the numerators together and get 19/12. Okay, it's the exact same process with rational expressions. Again, every step of that is a little more cumbersome, like finding the factors and multiplying the factors, and all those things are more challenging with polynomials, but it's the exact same process. Okay, this video was about adding and subtracting rational expressions. Thank you for watching.